Good morning, my viewers. This is Samuel Jude Ayodele, your Smart Tutorial founder. Welcome to today's class. Today we'll be looking at entity. In our previous class, we've talked about coefficients of unknown. That is the number attached to the unknown. And it does not determine if a particular number or if a particular entity are like terms. What actually determines like terms and unlike terms are the unknown or the entity itself, not the coefficients. Are we together? So with that knowledge of that, we'll be moving on to look at entity today. Entity, they are of two types. Either they are like terms or they are not like terms. And why do we classify entity as like terms and unlike terms? The reason is because of addition and subtractions of these variables. That is, the unknown or the entity or the terms, they can be added and they can be subtracted if they are like terms. If they are not like terms, they cannot be added together and they cannot be subtracted together. Unlike multiplication and divisions, they have a kind of glue effect. We'll talk about that in our subsequent upload. Today, we'll be looking at the like terms and the unlike terms. Under the like terms and the unlike terms, we are going to be looking at some aspects. The first one is numbers. How do we know a number? How do we know numbers that are like terms? Let me tell you, all numbers, they are like terms. All numbers can be added and subtracted without any stress. So far, you can do your counting and take away. So that is numbers. All numbers are like terms. Then the other aspects of like terms and unlike terms we'll be looking at is the alphabet. Under alphabet have case and type. So if an entity are like terms, that means they must have the same what? Case and type. For example, small letter x and small letter y, they are different. So you cannot add them, you cannot subtract them. Their answer will still remain as what? S plus y. That is, they are unlike terms. Same thing goes with small letter s and small letter x. They look alike. They are what? Like terms. Now look at this, 2y minus 7y. This is the coefficient. The coefficient is not a problem. The problem is the entity. That is the y, small letter y, and the small letter y. They look alike. They are what? Like terms. So that is 2 minus 7, which is what? Minus 5y. That is, they are same entity. They are like terms. That is why we are able to add and subtract them. That is, 2 of y minus 7 of y will give us minus y. It's just like 2 houses minus 7 houses. It will give you minus 5 houses. That is just it. Look at the other one, a plus 3a. Small letter a, capital letter a. So they are not the same. You cannot subtract them if they don't have the same case and the same name. So that is why we have this answer, that is, they are unlike terms. That is that under alphabet. We'll be looking at sword. For the swords, sword simply means square root. So don't forget, sword 2, square root 2. So in the sword, what you'll be looking at is the number or anything that is inside the sword. That is under sword. How do you know if they are like terms or unlike terms? That is, you have to look at what? The inner portion of the sword. Let's look at some examples. Root 2 plus root 3. Root 2 is different from root 3. Yeah, they are not ordinary number again. Root 2 is not a number, it's a sword. Root 3, that is sword 2, is same thing as root 3. Don't forget. So that is why, so far they are different. So the answer will remain like this. The same thing, root 3 plus root 3, that is, they are the same. They are like terms. Root 3, root 3, root 3, root 3. That is, that will be 2 of these. 2 of what? Root 3. So the same thing goes here. Let's look at this last example here. That is 5 root 2 minus this and this and this. If you look at it very well, you discover that root 2 is here. We have another root 2. So this one are what? Oh my God. Now look at it. We have what? If you look at this last one, we have root 2 and root 2 here. That means they are like terms. We have root 3 and root 3. Root 3. This 4 is coefficient. It's not the entity there. This 4 is just coefficient of root 3. This 5 is coefficient of root 2. So that means the root 2, they are what? Like terms. But this one and this, the root 3 and this one, they are not like terms. So root 3 and root 3 here are like terms. So that is why 5 of root 2 and 3 of root 2 will give us 8 of root 2, because it's what? Addition. This one is minus, this one is 1 root 3. That is just the secret. Also, this one is what? 4 root 3. They are what? It's just 1 boy, 4 boys. So if you take away 1 from 4, it gives you what? 3. So the root 3, that is what? 3 root 3. That is just the secret. The other one we are going to be looking at is the logarithm and power. Under the logarithm, before an entity can be referred to as like terms, they must have the same base and number. It's quite unfortunate that some students cannot even pronounce logarithm of entity very well. For example, log 2 base 3. There is a way you pronounce it, there is a way it is written. So let's look at it. This is the number, this is the base. The base is under the logarithm. Don't write the base under the number, please. The base is under the logarithm, not under this 5. Take note of it as a student. So logarithm must have the same base and same number. That is log 5 base 3 plus log 5 base 3. This is the entity. This is not a number. Don't mistake this for a number. It's not just ordinary number. It's what? This is an entity as a O. Log 5 base 3. This one, log, that will be 2 of this added together. This is 1 of this. This is where the coefficient is here, 1. Here is 1. Nothing is there, is 1. That is why it becomes what? 1 boy plus 1 boy will give you 2 boys. That is the secret. So the same thing applies there. This is log 5 base 2. Log 5 base 3. That means the base has made the difference. So they are not like terms again. So that is why the answer will remain as this. The same thing happens here. The number here is 3. The number here is 5. So you see, the 3 and 5, the base are not even the same. The number are not the same. Even though if the base are the same, if the number are different, you cannot add them. Now, that is why we still have this. That is no change from the question. The question is still our answer. Now, let's look at this. Log 3 plus log 3 base 10. Log 3 is the same thing as base 10. That is another secret we are trying to point out. If there is no base in anything, that thing remain as base 10. That is it. They will not tell you. Your textbook will not reveal that to you, though. So that means our answer, log 3, is 1 of log 3, 1 of log 3. So that is what? 2 log 3 base 10. That is the final answer. Then we move to power. Under power, we have for power, it must have the same base and power before you can refer to them as what? Like terms. That is s plus x. This one is raised to power 1, raised to power 1. So the power is the same. The base is the same. That is 2s. Which is still the same. The s is still the same thing as power 1. The power will not change. That is the answer, s plus x, the same alphabet, don't forget. So it's what? Book plus book. 2 book. S plus s, 2s. In mathematics, we don't care about the plural form or singular form. That is just it. So don't bring that to mathematics. So s square plus s square is just like someone having 2 heads, even though if the faces are the same. If the head are not the same, that means they are different. That is just it. So this one is s squared, this one is s squared. How many s squared do we have here? 1. Plus another 1 s squared. That would give us what? 2s squared. Because they are what? You can add them together because they are like terms. S squared plus y squared. Though the power is the same, but the entity is different, so you cannot add them. The answer will still remain as x squared plus y squared. So it gives you this. So let's look at the last one. This last one have helped us to highlight some of those that look alike. That is s cube. S cube. That means they are what? Like terms. S square and S square, they are what? Like terms. So you treat this together by collecting the like terms. You treat this together by collecting the like terms. So this one is 3 minus 5. That is what? Minus 2s cubed. Then plus 2s squared minus s squared will give you, that is 1 minus 2. So that is 2. This is plus 2. Plus 2 is the same thing as 2. So 2 minus 1 will give you how many s squared? It will give you what? 1s squared. Remember, in mathematics, 1s is still the same thing as x. 1s squared is still the same thing as s squared. So that is that for today. If you want to learn more, you can always contact us directly to personalize our service. Terms and conditions apply. Smart tutorial still free on Facebook. You can always search Samuel Dino on the YouTube, then you get more of our uploads on mathematics. Also, remain with us on the smart tutorial. Always comment, ask questions. We'll try our best to give you the best. So I still remain Samuel Dino, the smart tutorial. We expect your messages, and we also expect that you recommend us to friends, family, schools, so that they can also join the community. We can learn together on Facebook. And also, don't forget, you can also personalize our service. Our online and home service is affordable and is very easy and very effective, and also cost friendly. Thanks and have a wonderful time.